Hello, Chem 165 students. This is Dr. Foley, your instructor. This is going to be a different experience for all of us because the lectures are going to be all online and we're going to meet for discussions and labs in person. But I wanted to show you the textbook that we're using. Hopefully you were able to get one at the bookstore or maybe from Amazon.com, something like that. But it's a good textbook. You've probably seen general chemistry books before. Or any general science book is pretty much the same no matter which one you look at. They all cover the same topics. But if you do have any difficulty getting this book, let me know, because I do take a lot of information directly from it, and all the problems that I've suggested that I would like you to do are from this actual edition, the 12th edition. So it is important that you have the 12th edition. I'm not sure if the newer editions have the same sequence of problems and things like that. But the first chapter we're going to discuss is just an introduction to matter and measurement. We're going to just give you a review the vocabulary of chemistry and the basics of measurements before we can go on and talk about atomic theory and things like that. So this chapter, again, I'm going to try to follow the book as closely as I can just to help keep you organized. But these videos are going to be kind of long. We're supposed to meet for class 90 minutes 3 hours a week. So really these videos will be 3 hours a week. That's a lot of videotaping for me, and it's a lot of watching for you. I'll do my best to keep these videos 30 minutes or less and break them into pieces. But if I do put a long video on YouTube, you can just pause it and take a break. You don't, I don't know if you're watching it straight through. I don't expect you to. So the key to a class like this is to stay organized and stay on top of it. Try to do a little bit every day, and try to just stay as motivated as you can. So I'm going to have office hours online through Collaborate Ultra. They're at Thursdays from 1 to 3 p.m. If that time doesn't work for you, then you can always just make an appointment. We can talk about that when we're actually in person, or you can send me an email. I put a video where I reviewed the syllabus, so I'm not going to spend any time talking about the syllabus today. I just want to get into the material and then have a discussion next week where I give you some worksheets that you work on in groups together. So let me put this book aside, and I'm going to kind of do it the old school way. I'm just going to have sheets of paper. These aren't going to be polished videos, so if you're expecting to see a Hollywood movie, you've come to the wrong place. I'm going to make a lot of mistakes. I'm going to try to move with the tone, speaking and writing not too quickly, what I think would be a good pace. But if I move too slowly, then these videos turn into 2 hours long. But I do want to get through all the material. So if I go over 3 hours of lecture time a week, then you're just going to have to watch the videos, because I do want to stay on schedule with the topics we want to cover. So one question you might, why are you here? Why study chemistry? Now this course is kind of a survey. It's covering a little bit of everything. Why? I think everybody should have a chemistry background, at least a basic background that you'll have after you've finished this class. We're going to talk about all the important branches of chemistry: organic chemistry, inorganic chemistry. But chemistry fits into everything. They call it the central science for good reason. Chemistry will help you understand, for instance, what's in a bag of pretzels. I just took this. If you look at the label of a food, you'll see at the ingredient list all sorts of weird names: monosodium glutamate, buttermilk, dried onion. A lot of these are food ingredients. Carboxymethyl cellulose, calcium stearate, calcium lactate, lactic acid. Those are all chemicals, and you're going to learn how to draw those chemicals and how to name them. But chemistry is everywhere, right? Everything is a chemical. Even water is a chemical. Chemistry fits into kind of the center of all the sciences because chemistry is the study of matter and what matter is made of. So since that's everything, then no matter what scientific endeavor you pursue, most of you are probably going into engineering of some discipline of engineering, you need to know how you're going to be working with matter, so you need to know how matter behaves and what matter is made of. So chemistry is useful in biology because biology talks about animals, tissues, cells. Those are all made of atoms and molecules. Physics is the study or the science of how things work, but that's dealing with matter. Astronomy is chemistry is used in astronomy because astronomers, when they look at the light of distant stars, they're looking at the chemical makeup of the light to understand what that star might be made of. Does it have iron in it? Does it have hydrogen in it? Does it have carbon in it? Geology, very important to have a chemistry background because the study of rocks and minerals, those are ionic compounds made of metals and nonmetals mixed together. Even botany, the study of plants, is important. It's important to have a chemistry background. And medicine, biochemistry. Biochemistry is organic chemistry of living things, fats, proteins, carbohydrates, and especially in medicine. You know, these days with the whole COVID-19 pandemic going on, we're trying to figure out or get a vaccine. Well, of the vaccine that they eventually do come up with is going to be a mixture of chemicals and biological materials, proteins and things like that. But chemists are playing a big part in that because they'll be a chemist is skilled at synthesizing things and making things from raw materials. So there are branches of chemistry that are important. Any science is broken up into branches. Now, what is science? Science is just trying to explain the universe, right? The search for what's true. But science is a philosophy, so it isn't. It's just the humans' way of explaining what we see. So it's totally made up. It's just our philosophy of how the universe works. And now I'm using my phone to record these videos, so sometimes if the paper is a little off the page here, don't panic. I'm looking up at my phone periodically to see if I'm in the camera shot or not. But I studied organic chemistry. That's a big branch. That's one of the major branches of chemistry. It's a study of carbon. These are carbon-containing compounds. There's inorganic chemistry, which is the study of metals and catalysts that we use in our automobiles. Water is an inorganic chemical. Anything with carbon in it is organic. Anything that doesn't have carbon is considered inorganic chemistry. And then you have a branch of chemistry called physical chemistry, which deals with the physics of chemistry. How do electrons move and how do electrons behave in molecules? We picture electrons as moving with these funny shapes. These are called atomic orbitals, and we're going to be talking a fair amount about those. Biochemistry, like I said, is the study of organic chemistry of living things. So having a basic understanding of how proteins are structured and carbohydrates and lipids is useful to going into medicine. Even for chemical engineers, it would be helpful to have a basic understanding of those. But in this particular class, we're not going to spend too much time on biochemistry. We'll give you a brief introduction into organic molecules. And then another major branch of chemistry is called analytical chemistry. This is the science of dealing with studying chemical composition. What is a mixture made of? Most of what we come across in our daily lives are mixtures. They're not pure substances like elements or compounds. They're mixtures of things. And we have these analytical techniques that allow us to determine what's in a chemical mixture. NMR is just it's similar to MRI, which is used in medicine. NMR is probably the most useful tool that chemists use to determine the structure of a molecule. It stands for nuclear magnetic resonance. So it's we look at the hydrogen. I have a little picture of a model of a hydrogen molecule. It's just two hydrogen atoms bonded together. But most of our bodies are made of, we have a lot of hydrogen in our bodies, and these are like little magnets. So we can use an external magnetic field to cause these to interact with the magnetic field. And by doing that, and some fancy computer software helps us see inside the human body, and also to see what molecules are structured, or how they're structured. So that's just a little bit of an introduction into why we feel chemistry is useful for any college student. So let's just talk about the definition of chemistry. Definition of chemistry. Well, if you ask most people on the street, they'd probably say, well, it's a study of chemicals. Well, what's a chemical? It is the study of chemicals, if you really want to get, basic about it. It's the study of reactions. It's really the science of stuff. Stuff is slang for everything. But it's the science of matter. So matter is the term we use for describing everything. So anything that has mass. So mass is just anything that's made of atoms. Mass is an inherent quality of everything. We often talk about weight in our everyday lives, but weight is a little bit different than mass. Mass is something that never changes. And so matter is anything that just occupies space. So it's mass, and it occupies space. That's what matter is. We live in 3 dimensions, right? 3-dimensional space. Length, width, and volume. Now there's also something called dark matter that we won't dwell too much upon, but they believe, astronomers and nuclear physicists and astrophysicists believe that most of the universe is made of dark matter. We don't see this. This is unseen. But they have very good reasons why that most of the universe is made of dark matter. The matter that we're talking about in chemistry is matter we can see. My hands, the glass, this tabletop, it's a physical space. It takes up, has mass, it takes up space. That's what matter is. And I'm not telling you anything that you don't know, but I'm clarifying, and what we want to do is help you classify things a little bit better. Now, most of the universe is made of 2 simplest elements. Most of the universe is hydrogen and helium. We symbolize that with H and He. I'd say about 99% of everything is made of hydrogen and helium. And those, I'll show you a periodic table in a little bit. But those are the 2 simplest elements that we know of. And everything is pretty much a product of those 2 reacting together. So if in the centers of stars, if you take hydrogen and helium, there's like a complicated soup insides of stars. Hydrogen, helium atoms all mixed together, and they're under tremendous pressure. There's a lot of pressure on them. And this is going on in our sun as well. It's even going on in the inside of the planets like Jupiter, which are mostly gas. But out of that come all the other elements. All the other elements are formed by hydrogen and helium being fused together in what's called nuclear fusion. Nuclear fusion causes things to come together into larger pieces. And how that happens is things called supernovas. Supernovas are when stars die, they explode, and those elements that were part of the star are blown through the universe, and they've They make up the Earth, they make up you and me. We're made of atoms that were once on the insides of stars. Now there's a few videos I've put on Canvas. So whatever you see on Canvas under lecture videos, I've put there for a good reason. I want you to watch them. And now that I'm thinking about it, there's one video I want you to watch when you're watching these videos on Chapter 1. It's an astronomer by the name of Carl Sagan, astronomer. He was famous for being a professor at Cornell University. But he also had a famous series, sorry about that, I'm writing on a tabletop and it's kind of slippery. But he had a series called Cosmos, and you might have heard of that series. These days, there's a new astronomer named Neil deGrasse Tyson, who's kind of the modern day Carl Sagan. Carl Sagan was a huge influence on Neil deGrasse Tyson and present day astronomers, but Carl Sagan had a really good way of explaining things. So I encourage you to watch the video I've put. He talks a little bit about the chemical elements and where they came from. But you kind of just have to believe, us professors, because I'm just giving you information that I learned from other textbooks. So I'm passing this on to you. There's a lot of evidence to support everything I'm telling you. We don't really just make this stuff up. So I want you to trust that I will give you the correct information. If you find the reason I'm saying that is because there's a lot of stuff online that is wrong, especially even on Wikipedia. There's a lot of incorrect information. So just always be skeptical and question everything. So let's delve a little bit more into, and I'm going to try to use these colored pieces of paper just to give us a little, because you're going to be looking at this view so much. I wanted to give you something colorful to look at instead of just a boring white piece of paper. So I will try to make it a little more colorful than just a white piece of paper and black ink. So matter is also known as chemicals. Now chemicals, everybody says, oh, I don't want to eat that, or I don't want to use that. That has chemicals in it. Well, sorry, everything is a chemical. Hydrogen's a chemical. I've made some little models. Water, this is a little water molecule. That's a chemical. The oxygen that we're breathing looks like this. It's a little pair of oxygen atoms bonded together. That's a chemical. This represents nitrogen gas. So the air that we're breathing right now is 79% this, 21% this, and some other trace elements, a little bit of CO2. These are all chemicals. So there's really just good chemicals and bad chemicals. What do I mean by that? I mean, good chemicals are things like water, oxygen. CO2 is good in some ways. It does cause global warming, but we do need that. Aspirin, that's a good chemical. Bad chemicals would be poisons, but they're made up of the same elements as these. If you just change any molecule, even like aspirin, you just change a few atoms, you convert it from something that's safe to something that's deadly. That's what's interesting about chemistry and chemicals. The structures of molecules is dependent on the atoms that they're made of. So all these symbols I'm writing for you here: carbon monoxide, the deadly gas. You take one oxygen away from CO2, you get carbon monoxide, which can kill you if the concentration is really high. Hydrogen cyanide, those are bad chemicals, but everything is a chemical. And then we have another way of breaking up matter and classifying matter. We say it's either an element or it's a compound. Now elements, there's a little assignment. I want you to, and this will make your life easier in this class. I tell every chemistry class I teach to do this. Memorize the first 36 chemical element names. I'm trying to write reasonably fast, but I'll try to write as neatly as I can, but still not be too slow about it. Memorize the first 36 chemical elements. That's hydrogen to krypton. I think that's the first 4 rows. If you do that, you're going to be really ahead of the game as far as naming things and understanding what I'm saying in these videos. Compounds are things like H2O, CO2, even, there's millions, tens of millions of compounds. Chlorophyll. There's probably somewhere between 10 million and 500 million known compounds. These are all compounds. Now, this is a little hard. I might say this later on in the video as well, but this is a compound. This is a compound, but this is a molecule. So what's the difference? A lot of times teachers will say, and I'll do this as well, it's a molecule of water. Well, yes, it is a molecule of water. These are all molecules, but a molecule, technically speaking, is made of 2 or more elements, and a compound is made of 2 or more different elements. But we will use those 2 words, molecule and compound, interchangeably a lot. But these 2 elements, oxygen and nitrogen, are molecules because they're made of 2 or more atoms, but they're also chemical elements. Usually elements are just, and hydrogen is also a molecule, but it exists naturally as 2 hydrogen atoms bonded together. So when you look in the periodic table, let me see if I can find my periodic table here. I know I have one here handy. Here's the periodic table. There might be a little glare because it's in a plastic sheet. But you'll notice that the periodic table has symbols for everything, and they just list it as one single atom. But what you need to understand is that when we find these elements in nature on our Earth, some of them don't occur as single atoms. Most of them do, but 7 of them don't. Hydrogen is one of them. It occurs as H2. Oxygen is another one. It occurs as O2. You'll never see just a single oxygen atom floating around. And nitrogen exists as N2. And these funny looking things that are holding the atoms together, you'll use in one of the labs that we do this semester, you'll use these molecular models to make simple molecules like this. It helps you see the 3-dimensional character of molecules, because everything is 3-dimensional. It's not just images on a piece of flat paper. They actually have shapes, because water is actually V-shaped. It's not straight like a lot of textbooks draw. That's a mistake. But so these are elements that occur as molecules. So again, just keep that in mind. Be a little flexible in your thinking, and that when I say atoms, I don't always mean, or when I say an element, I don't always mean single atoms just floating around. So where was I? Oh yes, I wanted you to memorize the first 36, distinguish between elements and compounds. And if you really wanted to just think of the order of how things are made, we have atoms, which actually are made of electrons, protons, and neutrons. So if you mix, we're in the realm of nuclear physics as well. Those are the basic ingredients. These are the building blocks of the universe. People say atoms are the building blocks of the universe, but actually these are electrons, protons, and neutrons. So this is a symbolic science. This is why I think a lot of students have a hard time with chemistry, because you're not only trying to learn these all these weird concepts and varied concepts that don't seem to have anything to do with each other, but you're writing it. You're using symbols to represent things, because we can't see atoms, we can't see molecules, only with very powerful microscopes. So we have to imagine these things, and we have to trust that they exist. But what you'll see in this class is that we have lots of scientific proof to show and demonstrate that atoms really do exist. We see electrons, protons, and neutrons indirectly and we will talk about that as well. But you mix electrons, protons, and neutrons together, you get atoms, and atoms combine together to give you molecules. And molecules, or compounds, okay, combine together to give you mixtures. And that's pretty much it. That explains the organization of essentially everything. Now, most of what you encounter in your everyday life is a mixture. Just look at this bag of pretzels. That's a mixture. 2 or more different compounds mixed together is a mixture. And in a little bit, I will show you how we can classify this a little bit better. But there are many chemicals that you've come across in your everyday lives. So, for instance, I want to clarify that aspirin is a generic name. It doesn't really tell you what the structure is. But sometimes I'll write the name of a chemical. So when I'm at chemicals and their names. Aspirin's a chemical, but it doesn't tell you anything about the structure. This formula I'm writing now is sulfuric acid. That actually is the molecular formula of sulfuric acid. This is the formula for sodium hydroxide. But notice I'm taking, these are ingredients. These are atoms, but I'll sometimes call them elements. It's a periodic table of the elements. But elements are made of atoms. I know this can be a little bit confusing, but just that's why you have to work on this class, because there's a lot of abstract concepts. Ethylene is an organic molecule that we use to make polyethylene, to make plastic bottles. Ethanol is has the structure CH3CH2OH. That's the alcohol that's in wine and beer. This is in Drano. This is the most popular chemical produced in the world. It's used as a raw material in many, many things. So having a basic knowledge of chemistry is really important. It'll help you lead a better life, a safer life, and to understand what you're reading a little bit better.